So now on question 9.1, remember we are still on our June 2021 question paper, and it's very true that you have somehow gone through this type of a question, managed to prove, you remember your proportionality concept. So question 9.1, in the diagram ABC is a triangle. We are given the bigger triangle ABC. Then we are also given the point D and E are points on sides. So these are just points on the side, the one on AB and the one on AC respectively, such that these two lines are parallel, such that DA is parallel to BC. And with this statement, we are given, use the diagram above to prove the theorem. Which theorem is it? Which says that a line drawn parallel to one side of a triangle divides the other two sides proportionally. Proportionally. This is not the midpoint theorem. They are just proportional. That is, prove that this ratio is true. AD over DB is equal to AE over EC. So this is what we are given to prove on this diagram. We need this ratio of AD over BD, which is equal to AE over EC. All right, so we have gone through this type of a question, and by now I think if we just see this question, most of us, we just draw, we just like there's a tendency that we are now having, okay, which is fine. But I want you to know the proper way that you're actually having this, so that in an exam, or even if you're stuck, you know the original way of doing these things. All right. So in actual sense, what we needed from the concept is that we need the ratio of these two. All right. The AD over BD or DB is one and the same thing there. All right. So what we need is to have one and the same. All right, like I said, this was one and the same, guys. Do not panic on this one. All right, don't panic. It's just one and the same thing there. So what we need is that this AD and BD, which is these two, they are found on a single line, which is this line AB. AE and EC, they are on this line, which is AC. So they are properties that we can take from there, making our constructions from the line D to this point. Why are we actually making these constructions? The triangle that we are given, which is the bigger triangle, this one, ABC, this bigger triangle. And also, we're going to formulate another triangle that is going to be taken from A, B to E. They must have same height. They must have a same height. So we are going to use the point D as the common point. Remember here, take note D, D here. This is your common point D. So you join from the common point, which is D, so that they share the same height. It must be from the what? The same common point. And our common point is D. So from D to this line, we have got a perpendicular height. I don't know how are you going to name this height. You want to name it H1, you want to name it H2, you want to name it H, you want to name it K. It's up to you. I'm just going to name it H. Okay, the same thing, the point E and the point E, as we can see, it's a common point again. So you join from the common point to the base of the other triangle. As it goes to the base, it must be at 90 degrees. So we have got a 90 degrees from E and 90 degrees from D. But this is not enough, because the D that we have, I mean, this perpendicular height, which is our H that we are given, it is going to give us the area of the triangle that can be formulated from A, B, C, because we have got the height. There are two heights that we can consider there. So meaning to say, this is the height, this H here is going to affect this, everything on this base, everything that lies on this base must use H. The same thing, everything that is going to lie on this line, A, D, B, D, and as long as you're talking about A, D, B, the height that you're going to use is the one that is lying there, which is what? Which is K. So you are going to see that we are just limited to only one triangle. So to have another part, or to have other triangles, so the first thing that we're gonna have in this case is the construction. So we made a construction there. And what is the construction that we did? We joined this point to draw the perpendicular heights. That is draw the perpendicular heights in this case, all right? Then also do this so that you formulate another triangle that is going to use the same height of this one, K, meaning say from E, it must use the same height. So this triangle must be taken from B to E like this, then like this. It's a triangle. This triangle here, because of the issue of parallel lines concept, we're going to talk about that. All right. So you just join from B to E, then also join from D to C. Okay. So this is what we just did. Just join BE. So joined from BE and also DC. Okay. Then we have got our heights that we had. Remember the heights that we had. So like I said, because of the common points, this E, we had the heights from the common points, height from the common point, and also when you are constructing B to that common point E. So you can't join from E, which triangle can from E to C? It's impossible. So it's E to B, D to C. So are you seeing those common points, this D and the E? Those are the ones that you affect. You are working with those common points. That's why I'm saying you must be careful. It's not like, because they can change this. So most of us, we just draw, we just join. Okay, which is fine. At the end of the day, what you just need there is to have the full marks. But for those who want to know where this was actually taken from, this is the idea there. The common point, you join from the common point. So now, this is what you're going to do. You analyze here because already the ratio is given for you. It's given there. So you analyze to say, in order for me to have this AD here, it means I am working with this base of AD. So which triangle is using the base of AD? Which triangle is using this base of AD? It is triangle ADE. ADE. So I'm going to work with that triangle. Area of triangle. So I'm going to find area triangle ADE. All right. I ask myself the same question again. BD, this base of DB or BD, this one, this DB. Which triangle is using this base of DB or BD, this one? Which triangle is that? It is triangle DB to E, this triangle, this one. You take that triangle. It is the triangle with this base. So you are going to divide to the area of that triangle. B, DB, E, whatever way that you're going to take, or DEB, I don't know which way are you going to take it, but we just need this triangle, this one. So now let's calculate these areas of these triangles. The area of a triangle, which is a right angle triangle, that is the purpose of having these 90 degrees. We need perpendicular heights. We know that is taken from the half of the base times the perpendicular height. So from the half of the base times the perpendicular height, this is going to be half of the base of this triangle ADE is the one that you had from the ratio. So you must maintain that. Our base is supposed to be what? AD. So it is half of AD times the perpendicular height. Now take note. AD, this is our AD, this one. Which height lies on AD? This is your AD. Take a closer look here, AD. Which height lies there? This is the one here, which lies on AD, which is perpendicular to AD. The one perpendicular to AD is our K. So we are going to multiply to K. Everything over in this case, you're going to do the same thing. Half of this DEB, you maintain its base, which is the base is BD. This base BD, so it's going to be half of BD or DB, no matter way that you're going to take it, times the height. The height which lies on BD, remember this line DB here is the same line which is on AD. We are considering everything on this line. It is at the same perpendicular from E here. So we are considering the same perpendicular height that we had before of K. So that is our same perpendicular height. So what is happening with these two? They are the same, so you can cancel these two. You are remaining with AD over DB, which is this part. So we have got the first part. So as you can see, the answer, you are looking into the answer that you are given. Let it be there as a help. Let it just be there as a help. All right. So in this case, this is just a ratio that I formulated from the areas. I am going to do the same thing with the other part that I'm given of AE over EC. The AE and the EC are these two that are on this line AC. And these anything that is lying on this line is affected by the perpendicular height H. It is H that we are talking about this time. So in order for us to maintain the AE, we must have that on our base. So AE is supposed to be part of the base. So which triangle here has got the base of AE? It is triangle ADE. This triangle ADE, which is the same triangle that we had before. So meaning to say, you're going to consider the area of triangle ADE over which triangle has got the base of EC. That is the one that I need. EC. Which triangle? It is EBC. This is the triangle that I'm talking about. So it is area of triangle EBC or ECB, whatever way that you're going to have there. And the area of a right angle triangle being half of the base. As you are considering the base, remember what made you to take this triangle. It is because of this base that you want to maintain, which is the base of AE. Then the height from E to that base, from the point D to the base here, because we are considering our base as AE. Which line is perpendicular to that? This is H. Remember here, the one that is perpendicular. The one perpendicular to AE. Which line is this H? So meaning to say, there we're going to multiply by the perpendicular height, which is H. Everything over the area of triangle. This is triangle EBC. For EBC, I also have to maintain the base of EC, which is the one that I'm having on my ratio there, EC. So I'm supposed to maintain that. So it is half of the base, which is EC times the perpendicular height. As long it is on this line, AC, the perpendicular height to this line does not change. It is still H. They share the same height, so that height is going to maintain throughout. So just like the previous case, these two can cancel, and that means I'm going to remain with E over F. All right, AE over EC, this one. AE on top, that is AE over EC. This is what you're going to have at the end. But we cannot conclude because this is given as a statement that these two ratios are equal. Therefore, I just conclude that these two are equal. No, you don't just conclude. We have got a ratio AD over BD, which is same AD over BD. Yes. AE over EC, AE over EC, which is true. But this is not equal until you prove that they are equal. For now, they're just ratios. For now, they are just ratios. We don't even know about these ratios. There must be a statement that governs to say that truly these two are equal at the end of the day. So which part is it? Okay, let's consider this. If you check the top triangle, it's ADE. The top triangle is ADE. So there is no way triangle, which is the area in this case, the area of triangle ADE is definitely equal to the area of triangle ADE. It's the same triangle, ADE, only that we wrote it in different manners or in different ways. But it is the same triangle. So its area does not change because you used another base. No, the area still remains the same. These are the properties of a triangle that you're now taking into consideration. So the area is the same. Why? This is the common triangle. We are referring to the common triangle there. Now we must conclude because we said the top and this top are the same. So we must also conclude that the area in the denominator in the bottom is also the same. we must conclude that the area of triangle DEB is equal to the area of triangle EBC. And what is it? That they are the same. Why are we saying so? If we are to consider these two, what is going to make the area of triangle DAB to be equal to the area of triangle EBC on the base, area of triangle EBC, which is this one in the denominator and this one in the denominator? What will make these two to be equal? There is a property that governs parallel lines. There is a property about parallel lines. DEB, this triangle here, and this triangle EBC, they are under the same parallel lines. They are governed, they are under the same parallel lines. So it follows that if the triangles are under the same parallel lines, as you can see, having the same base, these two triangles, they are maintained by the same base, which is DE. All right. Oh, sorry. This is B. This is DEB, this one. And also we have got EBC, this one. So that is, they are within the same parallel lines. It's like this. If you're given, let me bring it this way. Parallel lines, what happens is that if two triangles are drawn like this, under the same parallel lines like this, they are going to have the same area as long they are from the same base. They must be from the same base, and they will have the same height. This height within here is the same for both, as long they are within parallel lines. The height there will be the same. So this is the major reason that you're going to put there to say they are from the same base. And not that just the same base, it is also the same height. This is because of what? Parallel line concept. This is about the parallel line concept. As we can see that DE is parallel to BC, since this DE is parallel to BC. Okay, so this is a property that is maintained on parallel lines. They maintain this property. So triangles that are formulated from the parallel lines, that is as long they are within the parallel lines from the same base, they are going to have the same height. No matter the height is not at the same point, but that height will be equal. That's why we are saying it is the same height. So therefore, there is no way that these two areas are equal. These two areas on top are also equal. Then these ratios will be different. There is no way like that. Because this is the same as what we see here. So it means its ratio must also be equal. So you don't conclude the idea of the ratios without this part. This is the one that is your final say, the one that gives your final say. So if it is like this, therefore it follows that exactly what I had from this area, which is the area of triangle ADE, over the area of triangle DEB is equal, because these two areas, they're equal, these two areas are equal, so it means therefore it is equal to the area of triangle ADE over the area of triangle EBC that we had before. And what is it about this triangle? It gave us this ratio of AD, so therefore AD over DB is equal to this one. What is it that we got from this? We got this ratio of AE over EC. So that is AE over EC at the end. That is our final say. At the end, we can conclude these two, they are truly equal. They are truly equal. So it's not that there's a lot there. Yes, I understand, guys, it's an exam time, so you just need fast, you're done. If you can do that, let's do that. We do not have time. But for those who are revising for the sake of knowing, who are writing maybe in November, because if you're writing in November, there's a time for that. But for those who are writing in June, guys, do whatever it takes for you to pass. I don't know what it takes. Is it to memorize? Is it to, I don't even know, because we do